Hello and welcome to this GCSE Science Additional Physics revision video on motion. In this video we'll cover distance time graphs, velocity and acceleration, and speed time graphs. Distance time graphs are a useful way of describing the motion of an object. They show how the distance moved from the starting point changes over time. When an object is stationary, the line is horizontal, so the distance does not change. When moving at steady speed, it is straight or a diagonal line. The steeper it is, the faster it is moving. If the line slopes downwards, then the object is returning to its starting position. If we have a distance time graph, using it, we can work out the speed that an object is travelling at. We can do this by working out the gradient of the line. So for instance, on this graph, it takes 4 seconds for the object to travel 8 meters. The equation for working out speed is distance divided by time, so therefore 8 divided by 4 means that the object is moving at 2 meters per second in the first 4 seconds of the graph. When an object moves in a straight line at steady speed, we can calculate its average speed if we know how far it travels and how long it takes. The equation speed is equal to distance travelled divided by time taken can be used to do this. You can calculate the acceleration of an object from its change in velocity and the time taken for this change in velocity. When an object moves in a straight line with a constant acceleration, you can calculate its acceleration if you know how much its velocity changes and how long this takes. The equation for this is acceleration is equal to change in speed divided by the amount of time taken. If we look at a speed time graph, we can go and use this equation to go and calculate an object's acceleration. So, in the first 4 seconds, its change in speed is from 0 to 8. So its change in speed is 8 meters per second. It takes 4 seconds to do this, so therefore its acceleration is 2 meters per second squared. Deceleration or negative acceleration is observed when an object slows down. The units are the same for acceleration, but the number has a negative symbol before it. For example, the car has slowed down by minus 1 meter per second. The velocity of an object and its speed in a particular direction can be shown on a speed time graph or a velocity time graph. Two cars travelling in the same speed but in opposite direction will have different velocities. Remember, velocity is the speed of an object and the direction that it is travelling in. Velocity time graphs can also be called speed time graphs. The vertical axis of velocity time graph is the velocity of the object. The horizontal axis is the amount of time from the start. When an object is moving at constant velocity, the line on the graph is horizontal. When the horizontal line is at 0 velocity, the object is at rest. When an object is undergoing constant acceleration, the line on the graph is straight but sloped. Curved lines on velocity time graph also show changes in velocity, but not with a constant acceleration or deceleration. The steeper the line, the greater the acceleration of the object. The purple line on this graph is steeper than the green line because the object represented by the purple line is accelerating with a greater acceleration. Notice that the line sloping downwards with a negative gradient represents an object with a constant deceleration, so therefore it is slowing down. Acceleration can be calculated by dividing the change in velocity, which is measured in meters per second, by the time taken for the change. The unit for acceleration is meters per second or meters per second squared. The area under the line in a velocity time graph represents the distance travelled. To find the distance travelled in the graph to the side, you need to find out the area represented by the light blue and the dark blue rectangle. The width of the triangle is 4 seconds and the height is 8 meters per second. To find the area, you use the equation the half times the base times the height. So the area of the light blue triangle is a half times 8 times 4, which is 16 meters. The width of the rectangle is 6 seconds and the height is 8 meters per second. So the area is 8 times 6, which is 48 meters. The area of the light blue triangle plus the area of the dark blue rectangle is 16 plus 48, so the total distance the car has travelled is 64 meters. So remember, when revising, start early, use flashcards to question yourselves, make sure that you are revising sooner rather than later, and good luck with your physics exam.